Objectives. At the end of the course, students will be able to know about relational algebra, understand the concept of relational operations such as selection, projection, set, Cartesian, rename, join, division. Understand the queries used in tuple calculus. Know the concept of well-formed formulae. Introduction to relational algebra. Relational database systems are expected to be equipped by a query language that can assist its users to query the database instances. The basic set of operations for the relational model, which can specify basic retrieval request and it produce new relations. There are two kinds of query languages, relational algebra and relational calculus. Relational databases are more usually defined using relational algebra. Definition: algebra is a set of operations and operands. Relational algebra defined in its basic form by E.F. Code in 1970. Relational algebra is a collection of operations to manipulate or access relation. It is a procedural query language which takes instances of relations as input and yields instances of relations as output without changing the original relations. Instances of relations, query, instances of a relation. Furthermore, relational algebra defines the complete scheme for each of the result relation. Relational algebra consists of set of relational operators. It uses operators to perform queries. An operator can be either unary or binary. Each operator has one or more relations as its inputs and yields relation as its output. Thus, both the operands and the results are relations, and so output from one operation can become the input to another operation. The relational algebra is a relation at a time or set language in which all tuples, possibly from several relations, are manipulated in one statement without looping. Introduction to relational operators. There are many variations of the operations that are included in relational algebra. Originally, 8 operations were proposed by Dr. Code, but several others have been developed. These 8 operations are divided into the following 2 categories. Set theoretic operations makes use of a fact that tables are essentially set of rows. There are 4 set theoretic operations: union, intersection, difference, product. Native relational operations focuses on the structure of the rows. There are 4 native relational operations: projection, selection, join, division. Operators in relational algebra are not necessarily the same as SQL operators, even if they have the same name. Relational operations. Fundamental operations of relational algebra are selection operation, projection operation, set operations, rename operation, join operation, division operation. Selection operator and its operation. The select sigma operator is used to select entire rows, that is tuples, from a table, that is a relation. Terms used in database table: SID, student ID; SName, student name; ranking, student rank; age, student age. Here in this example, S2 table got selected according to the condition where the rating, that is the column value, is greater than 8. Projection operator and its operation. The projection pi operator is used to extract entire columns from a table, just as select extracts rows from the table. It constructs a new table from some existing table by selecting only specified columns of the existing table and eliminating duplicate rows in the newly formed table, that is, a relation. It can be used to change the left to right order of columns within the result, that is, new table. Here, in this example, age, that is column, got projected from the table S2. Projected table does not contain repeated values. Here, in this example, S name and rating column get selected according to a condition where the rating value is greater than 8. Set operators and its operation. 4 standard set operations are union operation, intersection operation, set difference operation, Cartesian product operation. Operator used for union operation is U. The union of two tables or relations is the every row that appears in either of two tables. In other words, union compares rows in two relations and creates a new relation that contains some of the rows from each of the input relation. The table on which it operates must contain the same number of columns. Also, corresponding columns must be defined on the same domain name. In this example, consider two tables S1 and S2. The union of S1 and S2, that is S1 union S2, returns table instance containing all rows that occur in either relation instance S1 or S2 or both. Intersection operator and its operation. The operator used for intersection operation is intersection. The intersection of two tables results only those rows that appear in both of the named tables are given as output result. In this example, let us consider two relations S1 and S2. Now, intersection of two tables S1 intersection S2 returns a relation instance containing all tuples that occur in both S1 and S2. Set difference operator and its operation. The operator used for difference operation is minus. Difference operator subtracts from the first named table those rows that appear in the second named table and create a new relation. S1 minus S2 returns a relation instance containing all rows that occur in S1 but not in S2. Cartesian product operator and its operation. The operator used for Cartesian product operation is cross. Cartesian product is also called cross product operation. It takes each row from the first named table and concatenates it with every row of the second table. The Cartesian product operation multiples two tables to define another relation tables consisting of all possible pairs of rows from the two tables. In rename operator and its operation. Rename operator is used to give a name of results or output of queries. Results of relational algebra are also relations but without any name. The rename operation allows us to rename the output relation. Rename operation is denoted by the small Greek letter rho, rho x of E, where the result of expression E is saved with the name of x. In this example, first column name SID present in S1 table and the fifth column name SID present in R1 table got combined. Then, first column name got renamed as SID1 and fifth column name got renamed as SID2. Join operator and its operation. The operator used for join operation is join. Joining is a method of combination of two or more tables in a single table. It brings together rows from different tables based on some specified condition. It requires choosing columns to match rows in the table. Join can be also defined as a cross product followed by selection and projection. Row in different tables but with the same value of matching columns are combined into a single row in the output table. Joining is the most useful of all the relational algebra operations. We have several variants of join. Conditional join. Conditional join defined as a cross product followed by a selection. R join C, S is equal to sigma C of R into S, where join is called the bow tie and C is the condition. Example. In this example, S1 and R1 tables got combined using join operation under the condition of SID column values in the table S1 is less than SID column values in the table R1. Equijoin. Equijoin performs a filtered Cartesian product. Filter out rows where the column that have the same name with a different value. Example. In this example, S1 and R1 tables got combined using join operation under the condition of SID column values in the table S1 is equal to the SID column values in the table R1. Natural join. Natural join is equal to equijoin plus projection. The join checks for equality of values of common attributes, that is columns. In this example, S1 and R1 tables got combined without any condition. Observe the above figure. From bottom to top, we can analyze, select, project and join operators used in relational algebra. Division operator and its operation. The operator used for division operation is division. Division operation of two tables named completed and DB project defines a table completed divided by DB project. Over the column result that consists of set of rows from table completed that matches the combination of every rows in DB project. See the tables completed, DB project and their division. In this, division of completed and DB project tables produces result table. The result table contains only two rows because task, that is column, in the DB project table has only two rows. Those rows are unique to rows present in task column of completed table. Introduction to Relational Calculus. Relational calculus is a non-procedural query language, that is, there is no description of how to evaluate query. Relational calculus query specifies what is to be retrieved rather than how to retrieve it. Relational calculus queries are expressed as formulae consisting of number of variables and an expression. EHB is equal to phi theater time pi title sigma actor is equal to Humphrey Bogart film screening. IDMS is used to transform these non-procedural queries into equivalent and efficient procedural queries. calculus has variables? Constants, comparison operators, logical connectives, and quantifiers. Expressions in the calculus are called formula. Relational calculus is closely related to predicate calculus since tables in a relational database may be thought of as predicates. For example, player, player ID, L name, F name, country, Y born, B place, F test. The expression player A, B, C, D, E, F, G may be thought of as a predicate, which is true if a row with A, B, C, D, E, F, G exists in the table player. Relational calculus exists in two forms: tuple relational calculus, that is TRC, domain relational calculus, that is DRC. Tuple relational calculus. Introduction to Tuple Relational Calculus (TRC). The tuple relational calculus was originally proposed by Dr. Code in 1972. In the tuple relational calculus, tuples are found for which predicate is true. The calculus is based on the use of tuple variables. The tuple variable is a variable that ranges over a named relation, that is, a variable whose only permitted values are tuples of the relation. It is more closely associated with natural language. It does not depend on the order of operation. Tuple relational calculus and relational algebra have the same expressive power. All queries in TRC can be expressed in RA and vice versa. In TRC, queries are defined using some of the sets such as constants, predicates, Boolean, quantifiers, parentheses. Constants. Let I be an instance of a database and Q be a relational calculus query. Domain IQ is the set of all constants in Q or I. Let Q of I denote the relation resulting from applying Q to I. Predicates. Comparison operators are predicates. Example: less than or equal to, equals, not equals, greater than or equal to. Boolean. Logical connectives such as and, or, negation, implies are Boolean operators. Quantifiers. There exists x, f of x for formula f with variable x. is true if there is some tuple which, when substituted for x, makes f true. For all x, f of x for formula f with free variable x is true if tuple substituted for x makes f true, that is, all tuples when substituted for x make f true. Parenthesis. These are the parentheses used in TRC, tuple relational calculus. Variables range over tuples. The value of an attribute of a tuple T can be referred to in predicates using T attribute name. General form of tuple relational calculus is T conditions. T is a tuple variable which ranges over all possible values of tuples, where condition is atomic, TA or per SB or TA or per constant. T tuple variable, P relational name, A and B or attribute names, or per comparison operator. Two conditions combined using and or one condition modified by not. A condition C, relation R and tuple variable T combined as there exists T union R of C for all T union R of C. T may be the only free versus bound variable. We can also use the notation T.A, S.B or relation 1 of T and relation 2 of S and C, where T.A and S.B are the only free variables. Simple example of TRC query is T or teaching T and T.semester is equal to F1997. Corresponding SQL query is select all from teaching, where T.semester is equal to F1997. Example of tuple relational calculus. Example. To find the names and IDs of all players, the relational calculus formulation of query is given: S.fname, S.lname, S.playerID or S union player. The result of this query is represented in table is shown in figure. It specifies the values of the columns first name, last name and player ID of all rows such that S is in table player, that is all players. Example 2. Find IDs of all players from India. The TRC formulation of query is given as E.playerID or E union player and E.country is equal to India. The result of this query is represented in figure. The above TRC expression specifies that we wish to retrieve values of the column player ID of all rows E such that E is a member of the table player and the value of the column country of E is India. Domain relational calculus. Domain relational calculus (DRC) is a calculus that was introduced by Michael Lacroix and Alain Perrot. DRC is very similar to the tuple relational calculus. The basis of DRC essentially is that a relational database consists of domains that represents sets of objects in the database. query language based on Domain Relational Calculus (DRC). So, a DRC consists of variables that range on a single domain of the relational database. This language uses the same operators as tuple calculus, logical connectives and, or, and not, existential quantifier, universal quantifier. The following query shows the general form of a DRC query. Player ID, L name, F name, country, Y born, B place, F test, F of player ID, L name, F name, country, Y born, B place, F test. Difference between relational algebra and calculus. Relational algebra, relational calculus. It is a procedural method of solving queries. It is a non-procedural method of solving queries. The sequence of operations to perform a particular request. The required operations without bothering about the sequence of operation to perform that request. It is prescriptive or rigid in nature, that is, it specifies the step to perform a given task. It is descriptive or straightforward in nature, that is, describe the desired result. The evaluation of a query depends upon the order of operations. It does not depend on the order of operations. It specifies operations performed on existing relations to obtain new relations. Operations are directly performed on the relation in the form of formula. It is more closely associated with a programming language. It is more closely associated with a natural language. The solution to the database access problem using relational algebra is obtained by stating which is required and what are the steps to obtain that information. The solution to the database access problem using relational calculus is obtained simply by stating which is required and letting the system to find the answer. It is used as a vehicle for implementation of relational calculus. Relational calculus queries are converted into an equivalent relational algebra format by Code's reduction algorithm, and then it is implemented with the help of relational algebra operators. Relational algebra operators are used as a yardstick for measuring the expressive power of any given language. A language is said to be complete if it is at least as powerful as calculus, that is, if any relation definable by some expression of the calculus is also definable by some expression of the language in question. The queries are domain independent. The queries are domain dependent. Well-formed formula WFF. In mathematical logic, a well-formed formula, shortly WFF, that is a finite sequence of symbols from a given alphabet. Just as in English, there are certain grammatical rules which a statement must meet if it is to make sense. It is a part of a formal language. A formal language can be considered to be identical to the set containing all and only its formulae. A tuple variable is a variable that ranges over a named relation, that is, a variable whose only permitted values are tuples of the relation. To specify the range of a tuple variable R as the employee relation, it can be written as employee of R. To express the query, find the set of all tuples R such that f of R is true. We can write as R f of R. Here, f is called a well-formed formula WFF in mathematical logic. Thus, relational calculus expressions are formally defined by means of WFF that use tuple variables to represent tuple. Rules of well-formed formula WFF. The general rule which each WFF must meet is that every connective must actually connect two statements or WFFs. Every symbolized statement in overall is either a negation, a conjunction, a disjunction, a conditional, or a biconditional. Specifically, for the negation, every tilde must be followed by a complete statement. True and false or WFFs. Each propositional constant, that is specific proposition, and each propositional variable, that is a variable representing propositions, or WFFs. If A, B, and C are WFFs, then so are negation A and B, A or B, A unidirectional B, and A bidirectional to B. If X is a variable representing objects of the universe of discourse and A is a WFF, then so are for all XA and there exist XA. Examples of well-formed formulae. Here are some more examples of WFFs. Summary. In this class, we have learnt about the relational algebra and relational calculus, relational operators, tuple relational calculus, well-formed formula.